All right, let's go ahead and do another example with the product rule, but let's do a brief introduction to something first. So the product rule, derivative of a product equals derivative of the first times the second plus the first times derivative of the second, right? This is just a much more compact way of writing it. So that's if you have a product of two things, just f and g. What if you have a product of three things? So in other words, what if you have f, g, h primed, where these are all functions of x? So in other words, what we're saying is, what's this? D dx f of x times g of x times h of x. So what's that going to be? Well, this is actually going to be derivative of f times g times h plus f times the derivative of g times h plus fg times the derivative of h. Okay? So that's going to take forever to write out in the long notation here, but that's just what this is going to be here. So see a pattern kind of forming here. The derivative is just kind of cycling through these guys, right? Derivative of the first times the second times the third, first times derivative of the second times the third, then first times second times derivative of the third. So we see that if you take a derivative of a product like this, the derivative is just going to cycle through each one at a time. So if we also, let's say we have f, g, h, and then I guess k, if we have k of x. So that's f of x, g of x, h of x, and k of x. If we want to take a derivative of that, then following the same pattern, that's going to be f primed g h k plus f g primed h k, and then plus f g h primed k, and then plus f g h k primed, like that. Okay, so the same kind of pattern is going to follow. Okay, the derivative just cycles through each one of these guys one at a time. Okay, so and the same thing's going to happen if you have a derivative of five products, or a product of five things rather. So the same kind of pattern is going to happen here. So how do we prove this? We're not going to do it here, but for if you want to think about it, you can use the fact that you know the product, or the product rule if you have a product of two things. So what you could do is start with FGH and then just kind of group F and G together as one thing. So you can think of this as the product of FG with H. So you can think of this as like actually, let's go ahead and just run through this real quick. It probably won't take that long. So this is going to be the product rule with two things says it's going to be this, right? So if we have this here, treat this as one thing. So what we really have is fg primed and then times h plus fg and then times h primed. Okay. So now fg, that quantity primed, we can just do the product rule again, and we're going to get f primed g plus fg primed, right? And then remember, all that's being multiplied by h. And then we have plus, we can drop these parentheses now, we have fgh primed. So then when we distribute this h, we're going to get f primed g h plus fg primed h, and then plus fgh primed. So that's where the product rule for three factors comes from. Remember, the trick was just to treat, group two of them together and treat them as one thing, and then just use the product rule for a product of two factors, right? And that's, the same kind of trick will work for a product of four factors, but that one, I promise we're not going to do that one. So let's do an example. Let's do an actual example now. Let's see. Let's get green. No, not green. Blue. So example 3, we're on example 3, right? Yeah. Example 3 with the product rule. Let's say we want d dx of 4x squared times e to the x times sine of x. Alright, so remember our product rule for three factors. So let's erase this and replace it with the product rule for three factors. It says f, g, h quantity primed equals f prime g, h plus f, g primed h plus f, g, h primed. Right? So we're just going to use that here. So basically what we've got going on is 4x squared times e to the x times sine of x. So you kind of got two options here because you got the 4. So you can pull the 4 out of the derivative because it's just a constant, right? Or what actually might be a little easier, leave the 4 on the x squared. So treat that as your first guy. So this would be your f, this would be your g, and this would be your h. So the reason is if we pull the 4 out of everything, then we have to make sure that, you know, we put parentheses around the entire thing and then multiply or distribute the 4 back at the end. In this case, it wouldn't be that bad, but it is just an extra thing to worry about. So if you want, you could just leave it on the x squared here and treat 4x squared as your first function. So this is going to be, just because it's the first one we're doing like this, we'll write it out in detail. This will be d dx of 4x squared times just the second guy times just the third guy. All right, and then plus, so that's this first term we just wrote here. Now we're going to do the second term. So plus 4x squared times the derivative of just the second guy, and then we're just going to multiply by the third guy. Okay, and then for the, so that's the second term we just did. Now for the last term, we're going to have plus 4x squared times e to the x times the derivative of the third guy, which is sine of x. Okay, so going back over here, d dx of 4x squared, now we can just pull the 4 out of this, right? And that's going to be 4 times the derivative of x squared. And what's the derivative of x squared? It's 2x. So we have 4 times 2x, which is 8x. And then we still have e to the x and then sine x. So that's our first term just done. Plus 4x squared, derivative of e to the x with respect to x is just e to the x. And we're still multiplying by that sine of x. And then what happens here, plus 4x squared e to the x, what's this? Derivative of sine of x with respect to x we know is cosine of x, right? And that's actually pretty much it. You know, if you want, you could simplify a little bit. There are some common factors that you can pull out here. But for most applications, or it really just depends on what you're doing. You know, if you have to take another derivative, we're not going to do that. But if you had to, it might be better to leave it like this. But if you wanted to factor out some stuff, you know, e to the x appears everywhere, right? So does a factor of x, and so does a factor of 4. So you could say 4x e to the x times 2 sine x plus x sine x, and then plus x cosine x. Okay, you could also say that. This actually looks a little less cluttered than this one, but it's just two ways of saying the same thing. So that's example 3 with the product rule.